latch basically. So there is actually the slight difference between the latch and the flop. Okay, both store the element, but there's a slight difference between the latch and the flop. What is the difference like? So latch actually sensitive to level. Okay, while the flop is sensitive to edge. Okay, so what it means? So you see, right, whatever in the here we will be having clock, and here it will be enable. Okay, so whenever the clock is rising edge or falling edge, whatever type of clock it is, it it sends the D right on that at that time, it's take that value for the whole clock period, right?
Yeah.
So basically, what it means, like we have learned the flop, right? So it means like the clock. Just recapping whatever we did,
Yeah.
and then this is D. D might be changing here. Okay, like this. This is D, and then what will the Q? Can you say me? What tell me what will the Q? Where the Q will change? Q will be zero here. Where Q will change?
On the rising edge of the clock.
Yeah, we can say rising edge. So at the rise, these are the rising edge. At this time, it will check the value of D, and that will reflect the Q. The Q will be here. Okay. At this rising edge also it's saying like 1.
Yes.
It will remain 1, and at this rising is saying 0. It will make 0. This is a Q. So it's saying like this is sensitive to the edge only. Okay. This edge and this edge. Okay. It's sensitive. But while the latch is sensitive to the level. Okay. Let's this is clock, right? Let's draw the same here. Okay. We say it's clock. We say it's enable. It doesn't matter. Okay. It's just a terminology. Okay. So in the latch, there's no clock, but there's a enable is there. Okay. So we say it's a enable. Okay. So
But
enable can be also same way. Okay.
okay.
Clock kind of thing. It does not matter. Okay. And then we make D. Okay. And let's draw the D same way. Okay.
Okay.
Here. But the behavior will be different. Okay.
Okay.
We will not draw the D same way. Okay. Otherwise, we will not see the difference because this is not changing. So I drawn the D little slighter lesser than this. Okay. But yes, a minute. If I make D here, little change. Okay. D like this. Still it will be same value, right?
Yeah.
No change, right? So now this D and this D is almost same, right?
Yeah.
So let's draw the Q. I said that it's sensitive to the level. Okay. And this is like high. Okay. Active high latch. Okay. So it will be sensitive to the enable level. Enable level. So enable, whenever there's enable high is there, it's sensitive to it. It will take the value, otherwise it holds the value. So see, at this time, this is a level. Okay. This is level. At this time, what is the value of D? 0. Okay. We can draw the level so that we know. So at this is 0. Okay. And they hold the value until in the low side. Okay. No change. At this time, it says like level is 1. Okay. And D is 1 in this whole level. Let's remain 1. and remain until this. Okay,
Okay.
and at this time also it is 1. Okay,
Hmm.
so I made it 1 here, but suddenly in this level only it is changing.
Okay.
So it's sensitive to whole level, right? So
Yep.
Q will also change here. And
Hmm.
will remain same. Okay, so the difference is like here the changing in the Q is immediately sensed in the latch when it's high, but changing in D at the level sensitive, it will it will uh, it will change in the Q, but here only sensing the rising edge of the flop.
Edge only. Yeah.
Yeah, so this is difference between the latch and the clock, latch and the flop. Okay, and then how we represent it, right? Basically, we remember right, the flop is like there's a D input, there's a clock, okay, then there is a reset, okay, and there's a Q, okay, usually this one. And however, in the latch, it will be like this. So there is no clock, so there'll be a D, okay, then Q, then reset might be there, and there'll be a enable, okay, and this is called latch. So it is even internally also it's similar thing is there. Only sensing is changed to enable rising edge or the level. Okay, that is a difference. And we rarely use this design. Okay, don't
Latch.
try to use. Always try to avoid it.
Okay.
Always use it. Okay, because it is not easy to mix design with the latch and then flop. And if we mix it, our we cannot like our design will be like some faulty. So we should have a proper way to mix the design with the latch and then uh, flop. Okay. And now let's see how the coding matters and based on what code it will create latch. Okay. Yeah, okay. So latch. So you remember what we have based on the diagram, what inputs is needed? Enable, reset, and D, three inputs. Okay. Enable. Okay. D, Q. So now we write again. It's a sequential circuit, right? We can. So we have to always use process and then some sensitivity list and begin and okay and process. So here, so you see the difference between the latch and uh, so what when it should sense like what it has to sense. Here it was sensing at the D. It is sensing only at the clock edge, right? Right.
Yeah. Yes.
But what it has to sense here? It has to sense the whole level, right?
Yeah.
Okay. And at the same time, it has to sense the D change also, right? But in the whole level, D also can change anytime.
Yeah. D and enable both.
Yeah. So D and enable must be there in the sensitivity list.
Mm.
Here, clock was enough. Why? Because at the clock, whatever value is there, it will take. But at the whole level, so difference between like I'll just to elaborate, like when it goes inside it, when there is a change, okay, then only it goes inside the process. Okay. So let's say we did not mention D in the sensitivity list and we just mentioned the enable in the sensitivity list. So it will go inside it. Okay. At this change, this is a change from 0 to 1. Right? It will go in this change. It will take this value. Okay. But it will not go again. It will keep holding the value. It will not execute this statement because it is not seeing any change on the enable and D since we did not mention in the sensitivity list, it will not go inside the processor. It will
Right.
not assign the q value, D value to the q. So that's why here that is the difference because here only one instance is there in the whole clock. At the same time we are taking the value. At this change we are taking the value. But here at whole level we are taking the value. Whole level means enable is not changing at the whole level. Enable is changing at two edges only. It go inside two edges if you put enable only in the sensitivity list. So we must have a D to sense this change, okay, in the sensitivity list. So we should have enable lock and reset. Okay, reset also we want. Okay. So let's design if first should be reset, right? As a top priority. Reset equal to take active high, let's say. Then Q gets take 0. Else, okay. Else there was a clock equal to clock to one. Here else enable, right? Else enable equal to take 1. Okay. Then Q assigns D. Okay.
Yeah.
And and else sorry, this is else is and else we should do anything. Else what we should do? Nothing, right?
Then
Because
it 0.
else it has to hold the value. Okay. Basically, we can write else you hold the value, right? You hold the previous value. But previous value we cannot write here, right? So let's say take q int. Okay. This will be q int. Previous value is what? Q int only, right? When it's 0. When reset is not also 1, when enable is not also 1, then at the time it is hold the previous value when the enable is 0. Okay. So but we did not declare the q. What is the error here? Q assigns q int. Hmm. Okay. You have clock here.
I think the
Oh, clock is not declared. Q.
not, yeah, it's not.
D. Okay, so now to understand this, let's see the elaborated design. Okay. What's creating latch, right? So enable and D and Q. So Q, this is in Q interest, and then Q, that is something to Q. Okay. One more thing. So if I, let's say, if I write here D, what it will create? Is it a latch?
Q,
Or let's say I made it 0. The latch?
mm, no,
Why?
because it depends on the enable. Uh,
Yeah, so it is not a latch. Why? Because it's not taking the previous value when enable is low. It is changing to 0. So it's not a latch. It is a mux. It will be a simple mux. You see the design. I elaborated. A simple mux, right? Because it is not holding the latch behavior is what when the enable is low, it should hold the previous value, which is from the high. Okay, that must be there. Otherwise, it is not a latch. It is a simple any other design. It may be mux. It will be a mux or any other logic combination logic. It will not be a sequential element. Okay. So this is difference between. See, it's simple difference. I just made it q into 0 or any value you can assign. Like T also you do. It is not a mux. It is not a latch basically. Enable is not so you see it has optimized it. Irrespective of enable, we are assigning D, right? Both conditions. So enable is not needed because irrespective of that we are doing it, right? And then it's simply a mux, it takes D or return reset, right? And one more thing, if we don't assign a else, what will happen? What it is doing when there is no else? So let's say in the simulation, you see, let's say when at this time, okay, uh, here it is falling is right, okay,
yeah.
right? At this time, what will happen? Uh, it will go in the process, right? Because it sees it sends the enable, right? It sends the enable, right?
Mm.
And so it sends the enable and it goes in the process. What it will do? Is it is true that time? This is not true, right?
No.
It will not do this, right?
Yeah.
Is enable is 1 that time? No, right? Because enable is 0. Enable becomes 0. It will not do this. So what it will do that time? It will not do anything, right? Based on the statement. So what it means? It's not doing anything. It's not doing anything means it's holding the value, previous
Mm.
value. right? So
Okay.
writing a default statements assigning the previous value in else or not writing anything means same. Okay.
Hmm.
So I mean to say the else writing else part with the assigning the q in previous value is same as this statement is same as not writing else. Okay. So let's see. I comment it. Okay. What is the hardware? It is again still the latch. Still the latch. Okay.
Hmm.
Okay. This is one part. Okay. I will. Let's do some. And I will not do simulation here because we understand like uh, from the diagram what it will do, right?
Hmm. Yeah.
I will still explain some latch concept or some coding errors. Okay. So let's do a new source. Okay. Source. I'll make say latch understanding. Okay. Latch X latch learning. Okay. Very important to understand the coding. Okay. Otherwise, we will like yes, we what we will do. We will try to learn a latch using some experiments. Okay. Let's say I am writing a mux. I am trying to write a mux. Okay.
Okay.
Mux basically we have a output, right? Out one. Okay.
Yeah.
And
So this is
out
2:1 mux, right?
goes to one mux. Okay. Okay. And I want to create another out two. Two mux. I want to create two muxes. Okay. But behavior is opposite. What is opposite behavior? Like when the select is 0, I want to select A in out one mux. And when the select is 1, I want to select A in out two mux. Okay. So opposite behavior. I want to create two mux and which selects opposite of each other. Okay. Then
So
it is
this
very simple. Yeah.
out to that is output. So it is, uh, I mean, for the 2:1 mux, there is
I'm
the.
telling like I'm going to create this.
Hmm.
I want to create 2:1 mux A B. This is 0 and this is select. out one. Okay, 2 mux. And there's in the same file I want to create another mux where this is B, this is A, 0, 1, select and out 2. It's possible to create in same file 2 mux, right? There's no,
Yeah.
yeah, we can do. It's just a design. We can do anything in the same file. Okay. So let's try to write the same code. We'll write this. Okay. I write process. What will A, comma B, comma select, right?
Yeah.
In end process. If select equal to take 0, then out 1 assigns A, huh? Right?
Yeah. Yeah.
Else out 1 assigns
Mm.
B. And this, and this. Okay. Okay. And same way I can create a output, right? But it's a reverse. Okay.
Okay.
So let's see what hardware is creating. So this we have to set that stop file and then open elaboration.
And that is not saved. The file is not saved.
Save. So what do you are expecting in the semantic? 2 mux, right?
Yeah.
The 2 mux is there, right? It's just opposite way. A is connected here and B is connected here. Okay. So can we like, is it good idea to have writing writing same behavior? We can do this also, right? Right.
Mm. Out to,
And
yeah.
then here we can you can delete, right?
Yeah.
Can do, right?
Yeah.
And here
Is A.
in the same
Yeah.
same we can write, right?
Yeah.
So what it creates? Let's see. It's just creating same thing, right?
Yeah.
Let's say I forget to write this statement. Now what will happen?
So out to is was assigned to A.
I forget it.
Mm. Okay, let me think. Select 0, 1. I think it will rearrange it because,
Let's see. Okay.
yeah, I think it will.
So as per me, it will create a latch for out two. It will create a mux, 2:1 mux for out one. So currently it's creating 2:1 mux for both, but now it will create out two. It will create a latch, and for this it will create a mux. Okay. So what it is doing? It's creating a till mux for out one. Okay, and for out two, it is creating a latch. Okay. What it's creating? So enable is what? Enable is inverted of select, right? So how it is making inverted of select? It is from here using when this is one. Basically, it's a not only, right? Because we are using the zero, right?
Zero.
So usually we create one, right, for the latch, but it since it's a zero, so it is inverting the G. G is basically enable. Okay, and how it's inverting it, like when it's one, it will make it zero. When it is zero, it will make it one. Okay, revert it, and then it is make rearrange the G, and then it will assign the G. So out to why it is out to is a latch, because we have not given a behavior of out to when it is when the select is other value, right?
Oh.
So it means any incomplete if or else statement will create a latch. Any incomplete. So we have not completed the else part. So we must have a else part when we are writing a latch, when we are writing a combinational circuit. I remember a combination. This is a combination, right? It is no clock rising edge. It is
So,
accepted. Else part is not writing accepted in the clock event, right? But it is not accepted in the without clock process. If you write without clock process else part, you're not writing else part in where there's no clock, it will always create a latch. So we must check the. So you see there will be a warning also. If I run a simulation synthesis, right, it will give a warning. Latch is there. I'm running synthesis. So is why it gives warning, because mostly we don't expect the latch in the design, so it gives us warning.
so is it something the behavior from the VHDL that it shows that this is not the correct design?
No, this is design is correct. See, latch writing latch intentionally is the correct thing. Like if I want to create a latch,
No,
okay?
yeah, I mean, here we forgot, for example, here we forgot, right, to write that statement.
Yeah,
So that's why it created that latch, and we are doing a
yeah,
synthesis.
yeah. Right, right. It's failing because problem is there here. Log license error is there. Yeah, we'll see this license later. Basically, it gives a warning to us. I will see this license error again. Why it's like this error is there.
I think the device was selected, right? Maybe it is showing something for that.
Okay, maybe I can change the device. I can change this. You can see. Now it's running. Inferring warning, inferring latch for out two.
Inferring
So
latch.
why it's warning is yes, like you see your design. Are you writing any intentional latch or it is created by mistake? Because very highly possible like it is mistake can happen. Why highly is possible? Let's say let's say we are writing a behavior where there is many. I've shown you like just two signal assigning, right? If let's say select is having multiple condition, let's say select is 4 bit, right? Okay.
Yeah.
Or I give a one more example. This is like I use if, right? Let's say I comment it. Basically, select can be let me comment it. I write so same thing we can write by the case also, right? You remember
Yeah.
case?
Yeah.
It's also conditional, right? You can
Mm.
write instead of this, you can write case. Okay, right? Let's
Mm.
say what it will do. You remember case also create mux, but it's create always parallel mux, right?
Yeah.
Let's do four input, right? We can do four input so that it's easier to. We are creating two output again, okay? And select maybe a four input, maybe select will be
Mm. Two input. One.
four input, so maybe so select will be 2 bit. So we say like four conditions. So what it's going to create? It's going to create up two parallel max for out one and out, right?
Mm.
Just take it back. C and D we are not connected, right? So it's that's why C and D is not connected. Let A B A B B C A D. I'm getting one offset, right? That we are getting two different things. D, okay. Two parallel maps, okay. Let's say I forget this. At here I forget somehow.
Okay.
What will happen?
It will does the same the latch, I think.
Yeah, why? Because at 0 1 it does not know what to do for the C. It will not do basically it will hold the value. It will previous value.
Mm.
So it will create a latch because it's holding the value. So this is highly possible if you have a bigger structure, a bigger select is there, like 4-bit select is there, and then 16 different 16 different conditions are there, and also we have let's say 10 outputs are there. It's highly possible like we may forget somewhere one statement, right? To do what to write, and if you forget there's we cannot know it like uh, without any warning given by the tool.
Yeah.
And even very difficult to debug also simulation if very big design is there, a latch is there or what is happening. So our first thing is there we should see the synthesis log and see if
Okay.
any latch is there or not. We must see.
Okay.
So let's see semantic for this. This is a latch is there. How
Yeah.
to latch. Any question in this like latch learning? So if I run synthesis
Is
again, it will.
yeah, but
I just running synthesis again, it will show like there is a latch for the output. It will give a warning. Parallel synthesis criteria is not met because we have inferring latch. Right? For part for out two.
yeah. So for
It
that,
will give how many output it will be like incomplete. It will give warning for those output all the those output.
so for that 0 1, when we are saying like when 0 1 output is B, and we are
Yeah.
saying output is not defined for 0 1. For that 0 1, the output 2 will hold the value.
Hold the value previous value. It depend on again. It will depend on select now. What was the previous select and that value it will hold.
Okay.
So right, like let's say previous cycle the select was 1 0. So it will take the D value right out to, and now it's becoming 0 1 select. So it will hold the D value. If let's say previous cycle the select was 0 0 and the out to was B, and now the select is 0 1, so it will hold the previous D value, B value. Understand?
Okay. So it
So it is
so
it's a memory,
because
right? So latch is memory. So whatever previous value is
yeah,
there,
yeah, yeah, that part I understood, but I mean it holds because there is no assignment, so that's why it has to there is no other option for it to
yeah,
keep
yeah,
the previous value.
yeah.
Okay.
So even if you not write the others part, it will create a latch when there's. But that's why I said well, you must write others.
Others.
But if this is complete, if let's say I write 1 1 and we don't write others, okay, then it will give a warning. Let's say I come, what it will do now? Can you say me? It is latch.
Yeah, out to sub is was D. In otherwise so
It is not a latch. Why? Because it
because
is
it
complete.
ended.
All four conditions are complete.
Yeah, it is ended there at 1 1.
And if we don't write, if this is complete, and if you don't write anything here, we must write. First of all, the case always need this. Okay. So we
Okay.
can either write null. Null is also option. Okay.
And that 1 1 also we can put in the others, right? The last condition.
Yeah.
1 1.
Either you can do that or you can do this way also.
Okay.
It is not a latch. It still mux because all the four conditions are mentioned above.
Yeah,
Possible
so it
conditions.
doesn't care what happens after that.
Yeah. Yeah. But still, you case statement like you must write the others. Other it will give you a warning. Syntax error. Okay, some mux is there. Any question? I guess good understanding is a right latch
Yeah,
and
yeah. So latch also has the enable, that is the clock only, right? I mean,
yeah.
in
So whatever condition is there, it will go as a enable. Okay, it will generate its own enable based on this select. If whatever there is, if it will based on that it will generate a enable.
okay, but it is not a clock, right? Like we were doing in the D flip flop. We had
It can be a clock. You can give anything. Select can be you can do like this. You can
it
give a
can be
clock.
constant value also. Okay,
Yeah, it can be clock. Does not matter.
okay,
But and the difference between the clock and this is there's no rising edge or falling edge mentioned here, and there is and the clock rising edge must be there or falling edge must be there. That is the difference. So for writing a rising edge, then it's definitely a clock. It definitely a flip flop.
so for the clock, we had the statement clock not equal to clock, something like that, to generate the clock,
Yeah,
right?
yeah.
Okay, so for here it is not required for to select
Yeah, here it is. Yeah, here it is not because it's a level sensitive. If you write a clock equal to one or clock event, it is like it is sensing the edge.
edge only.
Here,
Okay,
here we are not mentioning any edge, so it is like it's a level. So if anything is level sensitive and incomplete statement, it's a latch
okay.
because we are not sensing the level when other condition is low level. So it means like it's a latch. One, okay.
So in our example, what is the how the select is behaving? It is like the similar to clock, or it is some value we assigned.
Some value it is creating. So it's like there are four possible conditions. There's somewhere, see, if I let's say again do here. So it is creating latch. So you see the how it's generating an enable from the select. It will from here it will generate a enable. Okay, and
So,
enable is based on the select. Okay, so basically I just reload it. Enable is like a when so what is doing like when that particular condition is like 1 1, we are not doing anything, right? We're holding the value.
yeah.
So that becomes the low condition, right? And other two becomes the high condition of
Mhm.
enable, right?
Yeah.
These will become high enable when 0 0 is there, 0 1 is there, 1 0 is there. The enable will become high to the enable of the latch will become high 1, and when this is condition, enable of the latch will become 0. So that it will generate like, so you see it is generating the enable, right?
Mhm.
So how it is generating when the three conditions the enable is high, when the last condition enable is 0. So it is generating an enable from the select.
Okay.